Okay, let's get this started. Let's make sure the audio is working. Okay, let's get this started. All right. Today I'm Saturday evening-ish. Got some plans later, but now I'm gonna take care of some work that I've been putting off. I'm doing a couple of things. One, let's talk about audio. So when I'm doing some content development, and I've got something on EVP and VXLAN for IPv6. I've got for my EVP and VXLAN cookbook, and then also stuff for YAML for network administrators, teaching people YAML. But before we start, I want to do this. I want to talk about audio and how important audio is for any presentation, any kind of YouTube or whatever presentation you're going to do. One of my pet peeves is when I see people doing some sort of demonstrations, tutorials, etc., and they have really terrible audio. And let's see if my audio is actually good. Yeah, sounds good. So there's a couple ways to do good audio, depending on what your budget is. One of them, like I've got this mic right here. This is the Shure SM7B. It's got a cloud lifter, which is upping the gain, and it goes into a Focusrite DSP. Although I would not recommend a Focusrite again. I would get something different. And another way to do it is I have this DJI remote mic. It's a wireless mic, battery. It's a DJI Mic 3. And I'm going to switch to that. So you're going to get, so now it's not coming from this. It's coming from my wireless mic. It's clipped in by a magnet. Makes it very convenient. The only thing you have to worry about, so now I don't have the mic in my face. The only thing you have to worry about is don't take it to the bathroom with you, because that could get embarrassing. In. See, by a magnet. One of the mics that I really dislike, I'm going to switch to this mic right here. I really hate these. I got one years ago, and I'm about to throw it away because it's, you'll see, but I see people doing demonstrations, tutorials, etc. with this, and it's pretty bad. Well, listen to this. Okay, so now the quality of the audio should have dropped significantly. So if you are demonstrations, tutorial. So yeah, let's see if I can go live here. Listen to this. Okay, so now the audio for this thing is just terrible, so I don't ever use it. If this is what your audio sounds like, get something better, because it actually doesn't cost a lot of money. But you should have a good dialed in system. I also do some processing. So the mic is not, let me go back to the other mic, because I don't think you want to listen to this anymore. Go. All right, back to this mic. So I also do some processing. There's a little bit of EQ. There's something called compression and a noise gate. So a noise gate is going to remove or at least reduce the amount of breaths that you hear. Every time I'm taking a breath, it can be distracting. And it also, and the compression will balance out if the levels are a little bit too soft or a little bit too loud, it'll compress. So it raises the low levels and then reduces the high levels. So you can do that. I'm using OBS as my streaming software, and it has that built in. Some of the mics will come with some software that you can do that. So if you're going to do any kind of audio, this kind of stuff, get your mic set up. You can use any crappy webcam, and that's going to be just fine. But but the audio has to be pristine. If the audio is not pristine, people are not going to listen. If it's echoey, if it's tinny, if it sounds like that headset I was wearing, then the brain takes cognitive workload to try to clean up the signal, so to speak. And then it's going to reduce your audience's ability to absorb the information you're trying to give. So just wanted to talk about that. Okay, so the first thing we're going to do is we're going to do work on IPv6 on EVP and VXLAN gateway presentation. I'm going to do a video about this. I'm playing around with different backgrounds because I want to do dark backgrounds with white text, because I think in the days where I was traveling for teaching, it was always better to do black text on white backgrounds, because all the content was going to be on a projector, and on a projector probably with a bulb that has needed to be replaced for like 20 years. You're going to want to make sure you have as much contrast as possible. And it's just better, easier on the eyes if it's black text on white background. You can do some colors here and there, but that should be your default, black text on white background, if you're using a projector. However, we've had a big shift in the last 6 years where we've moved from projectors to screens. So phones, computer monitors, laptop screens, and even TVs. I watch a lot of content on my living room TV. It's a 65-inch TV. And generally speaking, that's going to be better if you have white text on a black background. So that's what I'm doing there. So I'm trying to make it interesting with some sort of like a little bit of, I don't know if I'm wild about the texture here, but that's fine. And and this presentation is about IPv6 for an EVP and VXLAN underlay, and how you can do IPv6 a completely IPv6 underlay. So no IPv4 addresses, no point-to-point interfaces on IPv6, and no IPv4 on point-to-point interfaces, and no IPv4 on your loopbacks. So talk about EVP and VXLAN structure. So whenever I teach EVP and VXLAN, I teach the 4 layers. We have the physical topology. That's how our leaves and spines are connected to each other. We have our underlay, with the only purpose of the underlay for EVP and VXLAN is to provide IP connectivity between the loopbacks. That's all we do. There's several different routing protocols you can use. And then the overlay is peering between the IPv4 or between the loopbacks. It's just peering MPBGP between the loopbacks, so we can exchange, like if a leaf 1 learns a MAC address, it's got to get it to the other leaves. So it does that through MPBGP with the EVP and address family. And then we have our EVP and services, which are going to be either IPv4 or IPv6. So the big point I want to make here, and so how do I want to make this point? I'll just copy and paste, and then I can do this and format object. So maybe I want to make them less transparent or more transparent, or I'll just change their color. Let's make them gray. I'll also do the same thing for their text. I'll also maybe make this more transparent. Nope, that's not going to work. And make them more gray. Make the outline more gray. Just de-emphasize everything. Because what we want to say is that whatever you're running on the for EVPN services. So these are going to be the Anycast gateways. So VRFs, VLANs, Anycast gateways, peering. Whatever you do there is not going to involve anything down here. Do the outline. So there's different ways we can make draw attention, call attention to something. So, like if we did this in presentation mode. Oh yeah, I got to take out the animations here. I'm playing more and more with animations. I think it would certainly be a double-edged sword. I don't know if I need to put this part in here. So I'm going to hide these slides. I might come back to them. So I'm just going to hide them. So where IPs are needed. So we've got our point-to-point links here. We get our loopbacks. Make that smaller. Because spines are just going to have one loopback. There's just going to be loopback 0. So that's going to be our for peering. And then we have our leafs. They're going to have, this is 12. And they're going to have loopback 1. So spine loopbacks for MP BGP peering. That's the overlay peering. I don't know if I'm wild about this. Should I do like a white outline? Sure, let's do that. And then leaf, loopback. All right, so as I go through this, so where do we need IP addresses? First, we need a point-to-point link. I'm gonna move this off to the side. I think it's a /30 for ISIS if we're using that. Let me look it up real quick. I think it's a /30. I might be wrong about this. Just save ourselves /31 or /30. And we'll do that. And I'll move this back. Because we're going to tell the story. We'll do the animations. So we need them on our point-to-point links up here. And then we'll do these will appear. And then we need our spine loopbacks and our leaf loopbacks and what they're for. Then appear and then appear. See what that looks like. So we got our spines and leaves. We need our point-to-points need to have IP addresses. So a /30 or /31 on each of the endpoint or each of the links on each side of the links. Then we need our loopbacks for our spines and our loopbacks for our leaf. Our spines are going to have loopback 0. Our leafs are going to have loopback 0 and loopback 1. That's not part of any of the RFCs. It's just a convention. We use loopback 0 for the MP BGP peering. So that's how we exchange EVP and routes, like type 1 routes, type 2 routes, type 3 routes, type 5 routes, etc. And then we have loopback 0, loopback 1. Loopback 0 is for that MPBGP peering, and then loopback 1 is going to be our VTEP addresses. So we need, where do we need IP addresses? And then we can do IP unnumbered, IPv4 with OSPF and ISIS. And then I think I'll just copy all of this. Get rid of all the animations. Actually, you know what? I'll do this. Copy paste. And with IPv4 and OSPF ISIS, we can do IPv6 unnumbered, or yeah, IP unnumbered. And I actually have some examples. So here's OSPF unnumbered. Let's do BGP, IBGP. Did I do? Nope, it's that. Okay. I think I did ISIS. Yeah, ISIS unnumbered. Oh yeah, did I do? Probably could tell what I did on my Ethernet interface. Yeah, I did a /30 for them. I wonder if I could have done a /31. I don't know. For ISS. All right, so it's nice to have like just a set of like every config possible, or every config combination for underlays and overlays. It took me a while to build all this, but it is quite nice. So I can just take this and then do, what do we want to do for an outline? Weight of 1. And then I want to fill it black and paste it like that. And make that text white. And Roboto Mono. Do I not have Roboto Mono? Roboto? I could do Orbitron. How do I not have Roboto Mono on here? I need Roboto Mono as a it's one of the free fonts. I think it's on fonts google.com. Get font. To install these fonts. Roboto Mono is probably my favorite of the mono-spaced fonts, which I use for like terminal windows, that kind of thing. It's probably an easier way to do this. Can I just right click? No. Do I have to restart this? Yeah, crap. Gotta restart it. Save. I wonder if I can just open up another one of these windows. What did I just have? Okay. You have to start them all over again. No, missed a couple. It's got 20 different variations. That's okay. And so one more. All right. Could have used Consolas or Consolus. There we go. But I like Roboto Mono better. Let's move that off to the side. And then I want something above here that says then it's 4. It's IPN number. It says a little title card for it. So we'll fill it with black. I'll do a white outline, or I'll do a yellow outline. I'll make it 1 point. I'll make that text white. And then I think I can do a join. I don't know if this will work. Union, combine. I was trying to get the two things to join there, but that's all right. Maybe I'll make that center. Sure, we'll do that. That's good for now. So IP unnumbered works with OSPF and ISAS. However, BGP requirements So BGP is TCP based and no broadcast or multicast. Each peer needs a unicast IP address. And unicast. A unicast. I thought it was if it started with val. That doesn't sound right. Okay. So probably should do some sort of diagram. I always try to use diagrams when I'm doing any kind of to add to the text, so it's not just all text. Make them bigger. Do a link between them. Router 1, router 2. And then we need some text for the IP addresses. So 10.150/31. And that will be white, and I'll do a black background. Do I want to make it center? Just to, yeah. Also, Roboto Mono. Then make an outline, make it 1 point. I wish I knew how to make like a theme. I gotta look that up. So I could change the defaults of all this. Like there, if you go to the design, you can click a theme and then you can browse for theme and you can save current theme, but I don't know how to change it here. Spicy water. One of my friends calls sparkling water spicy water. And it's stuck. I love spicy water. I'm more carbonated water than man. I didn't get it for a while. I would go to Europe and then they would like, do you want bubble, gas or still? And I would always say still. But I love carbonated water now. Because I used to drink a lot of soda or like Coke, like not the sugar-free kind, like sugar Coke. And I was drinking way too much of it. which you can do in your 20s, but I'm in my late 40s now, and that's too much sugar for me. So I don't drink sugar, and I generally don't drink sugar in my beverages now. Not for any particular reason other than like I don't like it anymore. Okay, so BGP is TCP based, so no broadcast multicast. Each peer needs a unicast IP address. So enter. So the next thing we can do is BGP unnumbered, because I think I've done that. It's not really unnumbered. We're going to combine two things, which are separate. So one of them is IPv6 link local addresses, along with neighbor discovery. So make this text bigger. That might be. Is that too bright? It's gonna burn people's retinas. It's my favorite color. Tic Tac orange. That's my favorite color. Like orange is my favorite color, and the specific variation of orange that I like is Tic Tac orange. Then we're gonna do a big old plus sign. Make that white. And plus, 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 plus. So RC 8950, which is formerly 5549, has been deprecated. Actually, let me look that up real quick, just so I'm not talking out of my ass. RFC 5549. It's been obsoleted. Okay, obsoleted is the right word. IPv4 network with an IPv6 next hop. All right, I'll be right back. I'm going to go to the restroom. Too much spicy water. And I'm not using this mic right now, but I'm still going to take it off because I don't think you want to hear me peeing. Be right back. All right, and I'm back. So we can do IPv6 link local addresses, neighbor discovery protocol. Already did a presentation on this, I think. Well, I know I did, so I'm going to what was my looking for? I did some sort of presentation that had all this stuff. Yeah, there it is. It was a Tech Talk Tuesday. Describe the overall. Oh, I like this background color. Yep, there it is. So I think one of the things that people get confused with RFC 8950 is one, people typically refer to it as 5549, although it's been obsoleted, which is pretty common for a lot of RFCs that supersede other RFCs. We kind of know it by the original one, but people confuse it with IPv6 link local addressing and neighbor discovery, which is not part of 8950. The only thing that 8950 brings to the table is an IPv4 network with an IPv6 next hop. So what do? We do a diagram of two switches. We'll do this diagram. IPv6 link local. And BGP and BGP. Don't want to put the. Let's do that. So this background, I like having this background color that's a little bit offset, but this is the Ubuntu background color for terminal. I don't know if that's the right one to go with. Maybe something more in the blue. Because that's a red. This seems a little bit cooler. Okay, yeah, we'll do that one. And then I want to change the other ones too. to be consistent. Okay. Still trying to work out a good theme that is consistent. Okay, I'll be right back. My tea is ready. I'm gonna check something unrelated real quick to this. It has to do with skydiving. Some drama with one of the skydiving gear manufacturers. Okay. All right, back to the matter at hand. So we get a. This is probably. I just need to put this part in. How we're doing link local addresses, and then we'll just copy that and put that into here. Need a way to signify that these are. I think that works. It's not gotten used to the way that they do numbering. So it talks about how link local addresses get done, and then I'll do this again. I'll do a show that they've connected. Okay. The cool thing is we let's do this, and so we don't need any of this. There we go. So we can shrink this down and change the fill. Because I was showing that we can do this without IPv6 or IPv4 rather. So I can T. Passion fruit flavor, not passion flute. Oh, I'm using GitLab mono. That's why I didn't have Roboto mono. GitLab mono. So I can do a place fonts. Okay. Yep, GitLab mono. All sorts of different mono fonts. Okay, so we're not going to do, we'll just do R2 router pure group. Make it even smaller. Okay. And then I want to highlight the fact that we are, so do a fill, no fill, outline of bright red, and make that a weight of 3. And then highlight the fact that it is, those are the commands. I'll probably do an animation of appear for both of these. So that gets us peering for IPv6 using linked local addresses without assigning any IP addresses. So the whole point about this is we're trying to get away with not assigning any IP addresses. But if our IPv6, so let's do a, we want a white outline. If the loopbacks are IPv4, let's do a text. Let's do a text. So if their loopbacks are IPv4, you need RFC 8950. Let's do some more animations. So this one will appear, and then this one will appear. Ask the rhetorical question, get the rhetorical answer. And then that, I've got some configs for that. Let's take the whole slide. And then these. There we go. Sorry for the slurping. It's hot tea. It's good tea. Get rid of R1 because that wasn't necessary. R2 was R3 in this example. There. Try to boil down to the minimum configuration needed. And part 2. Probably make this text bigger, easier to read. There we go. Do some highlighting. Center this a little bit. There we go. So if we're just announcing the loopback, so here's the example here. So we just need IPv6 unicast routing. We don't need IP routing over IPv6 interfaces. Just showing what the configurations look like. So loopback 0 would look like this. Indentations in EOS config syntax are 3 spaces, 3 white spaces, for your information. We don't need any IPv4 address family. Just do network. .128. 128. So what we're using for? So what we typically use for loopbacks? It's these little things that back mask IPv6. No, okay, 128. Because it's, IPv6 is kind of weird about their masks. Like a point-to-point link will have be a /64, which is like how many billions of addresses in between those two endpoints. Seems wasteful. We can actually see it in action. I've got it configured. I think I do. I can deploy. Yeah, deploy that. So many deprecation warnings. What version of Ansible am I running? 2.18, so I'm not even running the latest one. Man, Ansible really screwed up this release. 2.19 was a kind of a disaster of a release. I broke a lot of stuff. I broke almost everything in the networking world. Oh, I need to fix my filter here. There we go. It's a little better. Okay, so if I go to Leaf 1, show IPv6 route. Yeah, there we are. Now, when we're doing IPv6 addresses, we do need to give a little bit of locally administered addresses. There is a reserved space in IPv6 for non-routed internal addresses. Somewhat similar to 19.4. Somewhat like. Locally, I think they call it locally administered IPv6. Unique local addresses. So that's what it's called. Unique local addresses. Okay, so here, Unique local address uses prefix FC00/7. The first bit following the prefix indicates if set, that address is locally assigned. This splits a block into two equal sides. Prefix in the range have some character of common. They're not allocated by an address registry. Maybe using networks by anyone outside outside environment. They're not mathematically guaranteed to be globally unique, but this is okay. There should be a bogon address. So routers should have filters in place to prevent this from being exported or imported with border routers. I'm not sure what this means here. First bit following prefix indicates, if set, that the address is locally assigned. This splits the address block to equally sized blocks, FC00 and FD00. With the block with L equals 0, it is not currently defined. Global ID. Some sort of coordinated assignment for ULAs, but this has not been implemented. To FD0/8. Okay. I did not know that. That's a lot of addresses. It's 120 bits of networking addresses, which are pretty big. So I think I use, yeah, so this should be FD0. Try to stay within, so FE80 is going to be the link local addresses, but we're using some unique local addresses. So LLAs and ULAs. I'm trying to get this right. And then we have lots of opportunity. To encode values to the various what was it, 120 divided by 8. FD00 1 2 3 4 5 6 7 8 A B B B B. So 1 2 3 4 5 6 7 8. Two byte sections, okay. Fixing my ghostly in the corner there. Okay, so enabling 8950 and Arista EOS. So if we're just going to advertise IPv6 loopbacks and BGP. All right, I think that's good. And then I should do implementing this with AVD. Oh yeah, I should do some caveats here. Some caveats. Remember that IPv6 VXLAN NCAP, that the VXLAN overhead when end capping to IPv6 datagrams. It's 70 bytes instead of 54 IPv4. With AVD 5.7, have they got updated AVD to 6 yet? Okay. No, it's at 572. Okay. With IPv6 or IPv6. With IPv4 loopbacks, BGP IPv6 numbered with IPv4 or IPv6 loopbacks. Currently IPv6 backs are not tested by ANTA. So a couple of things I learned about AVD. So configuring this in AVD. Reminder that EVPN services can be IPv4 or IPv6. Yeah, another one is DCI. DCI might require RFC 8950 if DCI network is IPv4 only. Good possibility. We're doing data center interconnects. Is independent on underlay overlay peering. Is IPv4 loopbacks with IPv6 unnumbered for BGP. You can use IPv6 loopbacks only with IPv6 numbered using you can use for BGP. You can use ranges for point-to-point links. Don't need to say for BGP that's redundant. All right. So I'm going on for about an hour, over an hour. I think I'm going to shut it down for today.